Hello again. Welcome to week 3. Last week, we looked at the internet as infrastructure supporting applications. And we looked at 4 different applications as an example. Now we're going to look at how one host sending data to another host on the network actually works. We are going to be focusing on the transport layer. The overall goal for this week is to learn the principles behind the transport layer services. These include multiplexing, demultiplexing, reliable data transfer, flow control, and congestion control, as well as learning about the 2 main transport layer protocols, UDP and TCP. The transport layer runs only on end systems. This layer provides logical communication between application processes running on different hosts. The sending side breaks the application messages into segments and passes them to the network layer. The receiving side reassembles the segments into messages and passes them to the application layer. Via multiplexing and demultiplexing, the transport layer extends the delivery service between 2 end systems to a delivery service between processes running on these end systems. Multiplexing does the job of gathering the application layer data into chunks, encapsulating them, and passing them to the network layer. Demultiplexing is the process of taking those received chunks or segments from the network layer, de-encapsulating them, and sending them to the application layer. To do this, the transport layer header includes a destination port number that identifies the destination application program on the remote machine and a source port number that identifies the application on the originating machine. Now let's look at UDP versus TCP. UDP is a bare bones protocol. UDP provides a connectionless service. No handshaking to set up the conversation. It is analogous to sending a letter. Each UDP segment is handled independently. If segments are lost or received out of order, UDP itself cannot fix it. As a consequence, UDP does not guarantee delivery. Another way of saying this, the sender just throws the application layer data at the receiver and hopes the receiver gets it. One of the main challenges in internet development was to figure out how to achieve reliable communications between devices over a noisy and lousy medium with limited resources. TCP to the rescue. TCP, in contrast to UDP, was developed as a connection-oriented protocol. In TCP, the sender and receiver communicate with each other to set up and regulate the flow of application data. A simple analogy for TCP is a phone call. TCP is designed for a conversation between one receiver and one sender. It provides for the orderly data reconstruction and flow control. Once the reliability problem was solved, then the next problem was to figure out how a large number of devices can share the communication medium. We will look at 2 of the algorithms that have been developed to help TCP handle congestion control. This chart provides the contrast between UDP and TCP. You can see that UDP is faster than TCP and can support broadcasts. But if your application really needs reliable data transfer, TCP is the choice. That's it for the intro for this week. Read Chapter 3, except Section 3.4, and look at the related videos. For this week, complete the Chapter 3 quiz and the problem set, as well as your journal. Complete Labs 4 and 5, the mini-net traffic measurement labs. There is also an extra credit lab, Lab 4A extra credit. You have 2 weeks to complete this lab. Also, submit your completed programming assignment number 2. Finally, this would be a good time to start preparing for the midterm, which is coming up in 10 days. To help you prepare, there is a pre-final quiz available on Canvas this week. It is open until the day of the midterm. This quiz counts the same as the chapter quiz, but you can take it up to 10 times. Your highest score is the one that counts. There is also a study guide available in the Module 3 resources. The midterm is open book and covers the videos and texts for chapters 1, 2, and 3 and labs 0 through 4. The midterm does not cover section 3.4 of chapter 3, except for the opening page of this section and table 3.1. Also, the midterm does not include the material that will be introduced in week 4.